Hey, this is Lab Group 2A, and this is Lab 9 on Shat Cube Interferometry. I'm David, and I was the drawer for this lab, and I'm just going to go over the system. So as always, we start with the laser right here on its typical rotational and translation stage. This time we have a beam expander set up. We didn't have to add the high-quality lens for that this time, as we had one just built in right there. And we also had our spatial filter. Ours, unfortunately, was really dirty, and we did not have any Kim wipes, so that kind of proved hard for getting good results for this lab. We saw a lot of things we shouldn't have seen on our viewing screen, such as like dust particles, which kind of affected our results in the end, unfortunately. And here we have the Shat Cube, as Steve will explain later. And basically we have our testing surface right here. So for the first part we used a spherical mirror, and that kind of coincides along with the spherical back surface of the Shat Cube. For the latter part of the lab we had two types of lenses that we also tested for defocus and tilt. Unfortunately, we weren't able to complete the test all the way because the assembly wasn't appropriate for the lenses we had, so we were kind of just limited to just doing defocus. On the other side, we have our viewing screen. Here we could use polarizers to decrease the amount of light going through, as this lab utilized taking a lot of pictures with a camera, and so we basically just put a camera at the end, and because the camera already has a lens, we don't have to insert an eyepiece. So we have the camera right here, which takes the pictures of the types of fringes we see as we add tilt or defocus into the testing surface right over here.
Hi, I'm Brian Lacasse, and I was the recorder for this lab. And you can see here, this is our null fringe for the reference mirror, and or the closest we could get to the null fringe. And so the next thing we did is we examined some defocus, and you can't really see the fringes in this image, but in the next image you can see that the center has moved somewhere over here, and there are circular lines there. And for the other defocus location, you can see the center is probably over here somewhere. You can kind of see some line fringes here. They're kind of hard to see. You can also see a little bit of overlap of images here on the edges. This is from tilt because we've moved the centers of curvatures off one another, so we expect to see multiple images. And here you can see that they're even greater. And what's likely occurring is, since there's two, this is probably likely from the mirror, and this over here is probably backscatter from a back reflection in the lens or somewhere else in the system. There's not. You can faintly see that there are lines in this image as well. So pause. All right, so this is tilt and Y, and so it's basically the same thing. You just you can see that the image is, we have a strange image up here. Again, you may be able to see faint lines appearing in the image. These ones actually look a little more curved, so we probably had some defocus in our system as well. And so this is at a greater tilt. This image is moved further out, so you can again see very faint fringes. All right, so this is defocus and tilt. So this is our first image for this, and it has very slight tilt, and you can see again there are curved lines on the image here. And then for this next image, you can see that there's very dark lines here, and you can see that the center is right there. As expected, the circular images from defocus have shifted. All right, so this is for our first test lens. We've replaced the reference lens. This is the best image we could get. We showed in the setup that you couldn't rotate the lens at all from tilt effectively. So all you can see here is that there's very clear fringes compared to our last lens. And you can see that this is probably a defocus and tilt location. The center is probably around here somewhere and enveloping defocus rings. You can see another defocus location here. And again, you can see another image. For the next lens, acting as a mirror, you can see that there is very many fringes here, and so the system probably has a large amount of aberrations induced into it. The lines look slightly curved in this fashion.
I'm Steven, and I was the experimenter for this lab. I'm going to go over how all these fringes are made and what everything means. So here's our setup over here, and you can see the laser comes in and it gets beams and the beam splitter here reflects 50% of the light this way. And then we have our reference lens here in red and our test mirror here. And you can see that in the ideal case, we have the mirror in the perfect orientation where the wavefronts will match the reference lens and focus. They'll both focus the exact same part, and we see a null fringe on the view screen. That corresponds to best focus. This is the case where both the reference wavefront and the test mirror have the same radius curvature, and if you have this case if you have a perfect null fringe, then you have a very high quality mirror. Now here's the case of defocus. What happens in defocus is that now we're going to be moving the mirror back, so one of these radius of curvatures won't match up correctly. So here's sort of what it would look like. Here would be the reference, and here would be the test in one case. And you can see that as you vary from the center and go out, you see you'll have optical path lengths as you go out. And that if you make this rotationally symmetric, you'll see that it will correspond to concentric rings. And then finally we have a case of tilt, and this is similar to our shear plate interferometer, where our reference spheres vary linearly across the pupil. And you can see here how sort of the reference spheres would look, and that produces different path lengths in a linear fashion, as opposed to a quadratic here, giving us straight lines. Depending on how you tilt it, you'll get either straight lines down or straight lines across. And finally, when if you had defocus and tilt, you essentially would add a little bit of this and a little bit of that, and you get a good dish of food, or
Curved lines.
Curved
That one
lines.
too, yeah.
Curved lines, and you'll get the circle offset to this side, or you just add the two on top of each other essentially.